Well, good morning or good afternoon, wherever you are. I don't know what the right solicitation is in UTC, but welcome to the second six-man session. I'm Bob Hinden. This is Ole Krohn. We are the co-chairs of Six-Man. Next slide. Please note the note well. We should all have this memorized by now. Next slide. The usual administrivia. Thanks to Barbara and Shuping for taking minutes. We're not doing a formal Jabber scribe. If we will watch the Jabber if someone raises a question and they're not in the room otherwise. Next slide. So as we talked about earlier, this session we're going to have now is sort of structured around the way we normally do a working group session. We're going to have document status, a report from the spring compression design team, working group drafts, and two active individual drafts. For today, we have 2 hours. Next slide. Yeah, and here's the agenda. Any agenda bashing? And we will manage the time, but we have about a 20-minute buffer. So if there's good discussions, we won't cut them off. We'll try not to cut them off prematurely, but still want to make sure all the presentations get time. Next slide.
So if there are no comments on the agenda, let's quickly go through the document status. Since the last meeting, we have published one RFC. It's 8981 on the temporary address extensions, the revision of 4941. We have 2 documents submitted to the IESG. It's the gratuitous neighbor discovery work, and it's the segment routing OAM document. The gratuitous document is awaiting a new ID from the author, and for the OAM document, it's in last call requested state. The IPv6 application of the alternate marking method, that's on the agenda for today. It's just going through the last call comments, and it's on the chairs to do the write-up and advance that document to the IESG. The compact routing header document, it's still awaiting the SR design team. We have a talk on that just following now. And we have 2 working group documents. It's the minimum path empty hop by hop option. That's not on the agenda for today. And we have the improving the robustness of Slack by Fernando, and that's on the agenda later. Any comments on document status before we move on to the SR design team talk? No? Then please go ahead.
Hello, Charles. Do you hear me?
We can hear you. Please go ahead.
Okay. So, this presentation give a basic status report for the SR compression design team, and currently we focused on 2 drafts. One is for the compression requirement, and the other for the compression analysis. Next page. So for the requirement draft, I think we have almost finished this draft within the design team. We post a 05 revision, and we hope 6 mind working group members can also review that and feedback your comments. And the other draft is analysis draft. We just begin to discuss this draft, and we post the 00 revision already, but in this revision, I think we just give some template, and we have some proposed text for that draft, but we've not have enough time to review that within design team, so we did not post those proposals. But we are confident that we can generate a full version of the analysis draft soon. Next page. So this is a status for the requirement draft. As I just mentioned, in the latest version, we have included all the requirements we've received, and the design team have gone through all of them. Till now, only 3 of them with draft, but not unanimous consensus within design team. But anyway, we have a poster all of them. These 3 items we put it to appendix. I think we, if possible, we would like to get more comments on them. So compared to revision 2, the revision 5 moved the 3 items from appendix to the main text, which are the blue highlighted. I think these 3 items are very important items. They are SRv6 based, SRv6 functionality. So I think it's a big progress for the design team. We can get agreement on those items. And we also added 9 new items with the right highlighted text. And those items covers address planning, compression levels, and SR domain protections, security, and something like that. We think that as that are fundamental requirement for the compression solution. So from the design team point of view, we've almost finished the requirement draft. Next page. So for the requirement drafts, we hope to get more review and comments from Spring Working Group, because this design team raised by Spring Working Group at first, and then as well as we also would like 6mind members can review that, because there are some topics related to 6mind work. And if possible, we would like to call for adoption as soon as possible. That is the basic next step for this draft. Next page. Yeah, this is basic status for the analysis draft. In this draft, currently, I think the biggest progress for us is that we have decided to analyze the four proposals. These four proposals I list here. One is CSEED, the other is CRH, and VSEED, and UID. I think these those four proposals give different angles mechanism. I think they are all very useful. And for the CSEED solution, I think it combined two drafts. One is from microseed team, and the other is for the GSeed team. It provides a very simple solution. It doesn't need any SRv6 data plan or control plan change, and leverages the SRv6 network programming model. It provides two flavors. The next CSEED flavor reflects the microseed solution, and the replace CSEED flavor reflect the GSeed solution. Both of them are in the same framework. And for the CRH, I think many people in SixMine are very familiar with that. The co-authors also give us some description. They said that the CRH defined two new IPv6 routing headers, CRH16 and CRH32, and each seed map to a CRH5 entry. There is no change to IPv6 forwarding plan or address model, and just a minimal change to SRv6 control plan. And for the VSeed, it defines a set of seed behaviors to access smaller seeds within the SR header. It generalized the SRH for any size of seeds and prefix. It encodes only the VSeed in SRH, not any redundant prefix. So everything else uses regular 128 bits seeds. It doesn't require any SRv6 control plan change, and it also leverages the SRv6 network programming model. And the last one is UID. It extended the SRH to carry such as Ampere's labels or IPv6 addresses. It gives a basic mapping solution, a compressed SRv6 segment list encoding in the SRH. It introduced a UET flag to unify traditional SRv6 seed and unified seed forwarding behaviors. So it leveraged the SRv6 network programming model with some new flavors. So these are some basic information of those four different solutions. I think they are all useful, but we will do some analysis against the current requirement draft, because the requirement draft provides some metric, so that we can, based on those metric, to compare those four different solutions. This is a status of the analysis draft. Next page. So here are some completion plan for analysis. So before the IETF meeting, I think we have already done a lot of work. And next step, we have a rough plan. In the middle of April, we will complete remaining analysis text proposal for the design team review, because when the Spring Working Group writes the design team, they hope we can provide some consensus document to the working group. So we will do the design team review at first. And we hope to provide a preliminary version at the end of April, so that the people in Spring Working Group can review it and comment it. And at the late May, we hope to submit a new revision for IETF Spring Working Group and the 6-month Working Group for review, because the analysis draft included some solution, which is from 6-month Working Group. So we hope the review can be done in the both working group. That's all for the report. Thank you. Any comments or questions?
Thank you very much. Just jump to the queue. We have a few minutes to discuss this if there is anyone. This has also been discussed in spring, right? Okay, Andrew, please go ahead.
Yeah, I'm pretty much going to repeat what I asked in spring. What is the next step for things like CRH? We have to now consider the fact that you now have drafts on this list that are actively shipping in code. In production releases, there are people developing on top of those on squatted code points because there's no other option. And we're entering a phase where this has now been going on for so long that effectively the working group is no longer really getting any say in something that is being developed, because it's becoming a fait accompli. This is leading, and these delays are leading to the IETF, sadly, in my view, contributing to a lack of standardization. When products are being developed on top of code points that people are using, and at the end of the day, when those code points have to change because we can't get code points, etc., because of the delays, that's not good for the industry. That's not good for the operators. The vendors might not mind, but it's hurting the operators. And I find it really, really, really sad, the situation that we are in, because we seem to be facing a war of attrition on certain things. And I'd like to know from the chairs and from the ADs, when are we going to proceed? Because this has now been dragging on for a lot longer than a year. And I'm getting very frustrated because I'm watching things that I'm actively developing, knowing that I can't live without them, that I'm going to have to change them as a result. So please, can we get answers as to when things are actually going to proceed now?
Yeah, so chairs, could I give some response for
Yes, please.
comments? Yeah,
Go
so I think Andrew asked the similar question in last spring meeting. And for me, I always ask myself one question: why we come here for IETF meeting? because we want to standardize the best solution or the proper solution for operators and vendors. And here, I think the analysis draft here, we list at least 4 different solutions. And from my point of view, I don't know. And the members,
I think we lost audio, or is it just me?
I think he's back, or he's muted.
Wei Chang, I think we missed or lost you there for a second. Are you back with us?
right? So I think we here now we have not get the result. Which one is a proper one? We don't want to repeat the work one by one, and we don't want to split the industry chain. So I think the standardize something, we need to take some time. That is valuable. So thank you.
Thank you.
Okay, why don't we go to the next? We have 4 other people in the queue. So Ron,
Can you hear me?
We
yes.
can hear you.
First, I'd like to support what Wei Cheng said. Taking our time to get it right is important. But I'd also like to support what Andrew said. There is shipping code behind each of them, and squatting on code points is not a good thing. Early this year, the chairs and I started talking about an RFC 7120 early code point allocation, and I believe that's gone to the ADs.
Yes, that's correct.
So we're waiting on the ADs. I've been sending musical reminders every week. I hope everybody's enjoyed them.
I don't know if our AD wants to respond to that or give a status on that, Eric.
Yeah, one thing I wanted to understand for the IANA early allocation was the number of deployments, or can anybody speak to deployments that actually need to interoperate as opposed to within sort of one administrative domain? Or is there like a Linux kernel development work that's going on that would need something, a code point, to then be tested for interoperability with another implementation?
So Andrew, do you want to jump ahead and respond to that?
So at the moment, there is the Juniper implementation, obviously. There are at least 6 separate things that we are working on that are Linux-based. There is work that we are working on that is heavily DPDK-based. So there are a couple of things that we're working on with regards to this that are currently being held back quite bad. And they are pretty critical on the continent on which I operate, because this is something that we really need.
Understood. The things that you're working on are, well, the intention is that they will not be, they're not just experimental, right? They're, if they work,
They're very much not just experimental. In fact, within the next probably 2 or 3 weeks, I plan to take certain things live in market.
That's good to know. Thank you.
Ron, do you want to continue, or are you done?
Okay, let's try to get through we're sort of over time, so we have,
I'll go
Sweet.
next then, Darren. This is
Yeah,
Darren
Darren.
Dukes from Cisco. Yeah. So I just wanted to back up Wei Cheng on those timelines. I mean, on February 11th, I sat down and reread a few of the proposals and came up with analysis that I posted to the design team. And at the time, the design team decided that we couldn't hit the February 22nd date for publication with internal review. So we delayed releasing that content. But I think that mid-April is very achievable for the design team once we get down to work and once folks actually finish the review of the analysis that's been sent out. And the second point I wanted to make is, I guess it's a question on that 7120 question. So there's the implementation with Andrew on his network, but as part of that is, do the authors expect there to be no further changes and that everything would be backward compatible with that, with any code points assigned? I'm just curious on that point as well.
That's one of the criteria. And
Yeah.
in the communication that I've received, the author committed that the format was stable at this point, and that it wouldn't need any changes going forward.
Well, okay.
Is what Bob and Ole were told and what I was told. Do you have knowledge to the contrary?
I don't.
Okay.
With one implementation, it was, I guess it's surprising, but okay.
okay, let's go to the next, Ching Li. We seem to have lost Oli, and hopefully he'll be back soon because he has all the slides loaded up.
So it would be better to wait till then. And I thought there are a lot majority modification in the CIH draft. So I'm not really sure it is mature right now or not, because it introduced a lot of like PSP flavor, something like this, intro drafts. So no idea yet. It is premature, maybe.
Okay, and I'm not sure I can pronounce your name right. Zihibu, who? Go ahead.
Zibo from Huawei. I think CH draft introduced SW6 native service function training, and PSP behaves in the last version. I think this draft has been changed a lot. We need more time to review. Thanks.
And Andrew, did you have anything else to add?
No, I think I've pretty much said my piece. I mean, just like I said, I don't want a situation where I end up with, we have a bunch of requirements on the continent at the moment, which we kind of started our development work because we kind of felt that we weren't getting a lot of work done on the continent by the vendors actually looking at the fairly unique requirements that we sometimes deal with in Africa. And I don't want to see a situation where I'm building on technologies and being forced to go one way outside of standards because of delays here that have now been going on. When we first raised this, I was there in Montreal when we were asking for CRH adoption in spring, etc., etc. And this has been way too long, and it's actually really hurting now.
Okay, Ron, real quick, and then we're going to move on. And Oli's laptop has crashed, so I'm going to probably have to pick up presenting slides. But
Regarding the stability of the draft, the format of the extension header hasn't changed in, I think, about 18 months now. A couple optional elements were added to the CRH fib, mostly as a response to what was going on in the design team. They're optional, and because they're optional, they don't present a backwards compatibility issue. Finally, an early allocation, if it turns out that this doesn't fly, early allocations are taken back. So the risk associated with an early allocation is minimal, especially considering the fact we have 255 routing types to assign. Of those, we've assigned only 5 or 6 in the last 25 years. So I don't think there's any risk that we're going to run out of them. Risk of making this allocation is minimal, and I question why the opposition to it is so strong.
I think the whole purpose of allowing the Spring design team the time to do their review was part of why the entire CRH adoption call was essentially suspended. So if it were understood that code points for CRH did not necessarily imply interference in the Spring design team work, then I suppose that's one consideration.
Yeah, so for design team, I think we will try our best to provide our analysis draft to the both working group soon. Thank you.
good, thank you. Oli, are you back?
I am just back. Let me just get the screen share up again. I hope you reached a conclusion in my absence.
No, but we got through all the speakers.
You go through all the speakers. Oh, on the microphone queue. Yes. Would have been nice if you got through all the speakers. So then we're ready for Giuseppe?
Yeah, can you share slides again?
Yep.
Yes, I'm here. Can you hear me?
We can hear you.
Okay, good.
Please go ahead.
Thank you. As Ole said before, this is a recap about this draft that ended the working group last call in January. Yeah, this is about the application of the alternate marking method to IPv6. Next slide. Yeah, I will go through a few slides to summarize the main contents of the draft. So this is a draft. This slide just gives a high-level view of the alternate marking method. So there are two reference documents, RFC 321 and RFC 8889, about the methodology. The first one describes the base methodology that consists of batching packets based on time interval for packet loss measurement, and to select with a second flag a new set of market packets for delay. The second document generalizes the application for multi-point unicast flows and allows a flexible approach for the monitoring. In particular, you can select different subnetworks at different levels based on the needed level of detail for the monitoring. So next slide. How to apply these two RFC in IPv6. So the agreed way was to define a new option that can be encapsulated as hop-by-hop options or destination option header. And you can see the detail of this option. It's a very simple one. So the first 3 bits of the type field are all 0. This is important because it means that you have to skip if you don't recognize and data do not change in root according to RFC 8200. And the other important fields are about the 2 marking fields that are important for the application of alternate marking method, of course. And the other one is about the flow monitor identification that is required for a specific reason that I'm going to explain in the next slide. So it is important to say that only the source node writes this option header, and depending on what kind of measurement is op by op or end-to-end, the nodes on path or only the destination node will process this option. Next slide. Yeah, this slide just explains why we need to define this unification. This is required for some specific reason. It helps to reduce the per node configuration and also allow a flexible granularity for the flow definition. It simplifies the counters handling, and also it eases and simplifies the export of data. There was also some discussion about the disambiguation of this identification, but in any case, there are 2 options. If a centralized controller can instruct the nodes properly, can guarantee, of course, the uniqueness of this identification. While in case this identification is pseudo-randomly generated by the source node, there is a chance of collision, but it depends on the application. It can be enough to have a 50% of collision for 1,200 flows, but if this is not enough, to have more entropy, this identification can be combined with other flow information in the packet, for example, the IP addresses or the flow label. Next slide, please. This is just a recap about the alternatives. Also, we changed a bit the wording of this to be aligned with the RFC 8200, and thanks to Brian for this suggestion. So basically, you can have the destination option not preceding the routing header, and in this case, the measurement can be done only by the node in the destination address, or you can have an op by op option, and every router on the path can do the measurement, of course, if they support this feature. Otherwise, destination option preceding a routing header, and in this case, every destination node in the route list can do the measurement. Next slide, please. Yeah, this is just a few words about the security consideration. We also get some comments on that. Basically, we classify the security concerns on the harm caused by the measurement, because the alternate marking, as you know, implies some modification on the option header. But of course, this must be performed in a way that does not affect the quality of service. And the second one is about the harm to the measurement, because of course, this measurement could be harmed by routers that can alter the marking of the packet, also by injecting artificial traffic. In any case, the precondition and the strong precondition that is common for all these on-path methodology is that it is applicable to a controlled domain. Under this hypothesis, we can say that the network nodes are locally administered, and this kind of attacks can be avoided. In addition, an attacker cannot gain information from a single monitoring point, because you need a synchronization between different monitoring points to gain network performance information. So this is also another aspect that is in favor of this methodology. Regarding the privacy concerns that are very limited, because the limited marking techniques is unlikely to increase the existing privacy risks. And in addition, it is applied to the option header and without any release of user data. So next slide, please. Yeah, now finally we can go through the main changes after the last call. In particular, the main input from Brian were about the classification, about the hop-by-hop processing. We clarify within the draft that, of course, in theory, the 3 high order bits are all 00, and as I said, this means that you can skip if you don't recognize and data don't change in root, according to the relevant document. And RFC 8200 also mentioned that the nodes only examine and process the hop-by-hop option if explicitly configured to do so. Anyway, in practice, the things may be different, and we also highlighted in the draft that it can happen that a packet can be forced into the slow path, but this is not under our control, so it's up to the implementation. The other comment was about this is very good because we added a new subsection about the controller domain in order to better highlight this point, because this answered the question about the deployability of the methodology. And we also added the cross-reference to the RFC 8799. The other point was about the rewarding of the alternatives that I have already described before. And also Brian suggests to relax the condition about the uniqueness of flow monitor identification, because it may not be a problem in most of the cases. Next slide, please. Yeah, another input was from Greg Mirsky. Yeah, he also noticed that the alternate marking bits carried by the option header may affect the pattern queue. Of course, this is true, and we also add a paragraph in the security considerations. Anyway, we must also, it is important also to note that the relative small size, so only 48 bits of this option, and this together with this application to a controller domain mitigate this issue. Also, we got other editorial comments and changes by Bob and Ole. Many thanks for that. Okay, next slide, please. Okay, regarding the next steps, okay, with the last call ended in January, we have found an agreed way to apply this RFC to IPv6. Of course, questions and comments are welcome. Thank you for time.
So as I mentioned during the document status, we were planning on the next step for this was to close the last call and do a write-up and advance it to the ISG. Is there anyone who have any comments now that we need to do prior to doing that? Please jump into the queue. Otherwise, we will proceed on that plan.
Okay,
sounds like not.
Go on. So Fernando, you're up.
Okay, thank you. Bye.
Can you hear me?
We can.
Okay, cool. Okay, so I'm Fernando Gont, and I will be presenting the document Improving the Robustness of Slack to Flash Renumbering Events. Next slide, please. So essentially what this document tries to do is to provide mitigations for the problem that is discussed in RFC 8978, which is what was published a couple of days ago. It's the problem statement. You know, at the time, we have an individual submission that had like, you know, several kind of orthogonal mitigations for this problem. So the decision at the time was to, before actually incorporating into the working group document those mitigations, essentially, you know, discuss each of them in the working group, and, you know, based on working group consensus, decide whether or not to incorporate them into the working group document. We have made a lot of progress so far, and there's only one item that seems to be left. That is a mechanism to try to infer that there is stale information based on incoming router advertisements. Okay, next slide. So essentially, the individual version had like a proposed mechanism, and what we have and that that mechanism received quite a bit of discussion, and not everyone was happy with it. So one thing that we did since then is first of all try to take a step back and think about how these mitigation should work. Okay. So essentially, we can say that the mitigation for, let's say, getting rid of stale information has two parts. Part of it is the trigger, like something that happens in the network that makes you think that that might be an indication that there is information that has become stale. And then there is the second part, which is the actual check. What do you do to actually check that that information has indeed become stale? So the mitigation that we had essentially didn't separate, between these two parts, and it was just the mechanism proposed right away. So we kind of like rethought this idea quite a bit. When it comes to the trigger, that's probably the easy part. Okay, so the obvious trigger, for checking whether the information has become stale or not, is the receipt of a router advertisement that contains missing information. We are talking about PIOs in our case. And then there's the question of, what a host could possibly do to actually, check or double check if the information has indeed become stale. So here we have like, three different. Can you hear me?
So it's now you came back. We lost
Okay.
about 20 seconds.
Okay, so long story short, we reanalyzed the mitigation that we had, and what we did was separate it into two parts: a trigger and the actual check. The trigger is what will make the host say, okay, you should probably double check whether this information is stale or not, and the check is what you actually do to figure that out. The obvious thing for the trigger is the receipt of an array that is missing previous information. In this case, PIOs. Okay. Now, when it comes to the possible checks, there are like at least three different options. The last one is the one that we eventually selected, but I will mention the other two options too, because one of them is the one that we had. The previous option that we had, which is the one that was in the individual submission, was essentially that when you receive an array that was missing a PIO, essentially reduce the preferred lifetime and the valid lifetime. And the idea was simple. You reduce the lifetimes, and if they were not stale, those timers would be refreshed, and that's it. So you were not actually checking whether the information was stale or not, but reduce the lifetimes like to small values. For example, the preferred lifetime in the order of a few seconds, okay, or on the order of, let's say, 5, 10, 20 a minute, but small value, and the valid lifetime to a few minutes. Now, if they were not stale, they would be refreshed, and that's it. So the check was kind of like implicit, okay? There is another option, which is also kind of like an implicit check, which is to, for example, when you receive an array and it's missing information, rather than do like a more aggressive reduction of the lifetimes, for example, half these lifetime values. So the reduction won't be that aggressive, but you will eventually reduce like the lifetime exponentially. Okay. Now, what we finally selected to do, which is probably the most conservative option, is to do like an explicit check. So when you receive an array that is missing information, what you do is essentially you schedule that of sending a router solicitation to the router that sent you the information to double check whether that information is stale or not. If, while you have scheduled the RS, you receive the information, then that's fine. You don't even need to send the RS because the information is there. And in the case that you schedule that of sending a router solicitation, and in the meantime you don't receive it, then you do send a unicast router solicitation. And what we propose, which is in the next slide, is that you can. I mean, I personally think that if you check with an RAs once, that should be more than enough. But if folks want to be even more conservative, you can actually send an arrays like multiple times. So you retry multiple times, you poll the router multiple times to see if if the router eventually sends you that information that was missing. Next slide. So this is essentially what I just said, but with more detail. So the concept is exactly the same. This is just getting into the details. So the idea is that if we have a flag that is called router refresh, which if it's false, it means that it's like normal behavior what we have right now. And if this flag is set to true, that means that we are in the process of double checking with that router whether the information is fresh or not. So if you receive an array and you are not currently refreshing the information, then you check the PIOs. If any of them is missing, then that means that you have to enter this router refresh mode, if you wish. So what you do, you enter this, you set this flag, router refresh to true, and then you mark what are the PIOs that are missing. That is, PIOs that you had received from that router before, but that are missing in this packet. And the next thing that you do is you set a timer. You are scheduling a timer so that to schedule a router solicitation, okay? Now, if you receive an array, okay, and you were refreshing information, the only thing that router refresh was true, the only thing that you have to do is look at the PIOs and clear the ones that you just received. So you're keeping track of which ones are missing. So if you're refreshing information, then you check the PIOs, the ones that you have received, you clear them, okay? So that means that those are fresh, still fresh. Now, what happens if the timer expires? The timers that you had set up before expires. Well, what you do is, if all the PIOs have been received, that means that essentially all the information is fresh, so you just clear this router refresh flag. So you are refreshing information, but you have received everything that you were meaning to receive, problem solved, okay? Then we have a second option. If you have retransmitted a router solicitation more than whatever number of times the working group wants to do, it could be once, if we agree that once is enough, but it could be 10 if that's what the working group thinks is the most conservative option, fine enough. But if you have retransmitted the arrays that number of times, then essentially disassociate those PIOs with the router. That is, you have checked with the router, that means that that information has become stale, then you have to get rid of it. Now, in the other case, that is, the timer has expired, what you do is send a router solicitation. So the concept is quite simple. You get an array that has missing PIOs, you schedule a timer. If before the timer expired, all the information has been received in other arrays, then problem solved. Otherwise, you send a number of times, as many as necessary, unicast router solicitations to the router to double check whether that information is there. If you have retransmitted the RS in sufficient number of times, then you give up and you remove that information. Next slide. So comments. This is not necessary, so I could have easily removed this slide, but some things could be made easier, like even simpler, if all options of the same type could be required to be in the same array packet. This is, I stress this like strongly, this is not required for the mechanism that we just discussed, okay? I'm just saying that if we were to do that, if we were to enforce this other requirement, things would be even simpler, but this is not required. Okay, so if we were to require all options of the same type to be in the same packet, this could be even simplified, because right now 4861 essentially says that you can split the information among any number of packets that you want, even options from the same time. For example, you could have to send, like, say, 10 PIOs, and you can send each PIO in a different array. But again, this is not required for this mechanism to work. Next one. So question is if there are any comments or concerns about this. So the idea is that what was agreed was that things should be discussed with the working group before we would actually incorporate them into the working group document. So this is this part. If there are comments or concerns about this mechanism that we have proposed, and if there are not, we can send the detailed text to the mailing list, let's say for a final review or another review before we incorporate into the working group document.
Comments? So I think, yeah, we would like to see more review of this, of what's proposed here. So if I'd like to, if we can solicit some reviewers, if you're interested in doing this, please contact the chairs. I think that'd be very helpful. So there are a bunch of changes to a fairly basic part of IPv6.
Perfect.
Good.
Okay, thank you, Fernando. I think Bob, you might be the next one. Let me see.
I think I might be. Good. And Gory may, my co-author, may jump in. I think he's online. Yes. So if I get it wrong, he'll correct me. So I'm going to talk about the draft I wrote a while back for changing the way we process hop-by-hop options. I got the idea for doing this after some discussions at the last IETF meeting, and tried to write it all down to see if it would make sense. As usual, writing stuff down causes you to try to flesh out issues, and it ended up a little bit different than I thought. So next slide. So I mean, the underlying problem is that hop-by-hop options are not working end-to-end in the internet. It's common that packets with hop-by options get dropped. I think based on the measurements that Gory and Anna did regarding the PathMQ option, I think we discovered that there are some edge routers, the ISP who serves the actual customer were just dropping these. They didn't want packets to go to the slow path. They didn't want to have them interfere with the operation of the router. And so my conclusion was that, we need to do something different if we expect hop-by-hop options to be useful in the future. Because right now they're not very useful, and this is an approach to try something different. I think neither of us are sure this is the perfect solution, but it wanted to entertain thinking about this and how we might make this better. So next slide. Oh, and so by the way, so I'm going to basically, the way the presentation is organized, it first basically talks about what's in the draft, and then it has a section that goes through the issues that were raised in the mailing list discussion. And I think I captured them all, but then we can talk about, and then hopefully can have a robust discussion after that. So the terminology we're using in the draft is, fast path and slow path. And fast path means hardware forwarding, network processor forwarding, ASIC packet processing. It's the usual processing in the router for most packets. It's how you get wire speed. It's also a lot of times called the forwarding plane. And then the slow path is, where packets that are usually processed by the router go. In a lot of cases, it's software processing. So it's used for special processing. It's where routing protocols go and the like. It's also called the control plane. So, we're using fast path and slow path in this draft, but I think it's synonymous with forwarding plane and control plane. Next slide. So in the first IPv6 specification, it was required that hop options be processed by all nodes. At that time, it was not feasible to do this at wire speed in hardware. This was a while ago. Packets with hop-by-hop options were sent to the slow path. In fact, one of them, the router alert, was designed just to tell the router to go look carefully in this packet. But it was also then observed that this mechanism could be used as a denial of service attack because it allows nodes, any host on the internet, to send packets that cause the router to have to do a lot more work. And I think this is a big issue as to why they get packets with hop-by-hop options aren't processed. And then I think that it's made worse that we allow multiple hop-by-hop options in the option header. Next slide. The current specification changed this a little bit. It tried to document the reality when we published the IPv6 specification as an IETF standard, the last step in the standards process. And we basically changed it to only require processing if the router is configured to do so. And this basically matched what was currently being done operationally. And I also note, based on discussion, that, I think this is really only talking about routers with specialized hardware forwarding. Software-only routers, I think, don't have this issue, but I think the denial of service attack is still an issue even in software. Next slide. And motivation again is hop-by-hop options are not practical currently to be used widely. It's common to drop packets with hop-by-hop options. I think multiple options make the problem worse. And any mechanism that that packets that are sent externally to slow down a router can be exploited as a denial of service attack. And the goal when I wrote this was to redefine the procedures to make hop-by options more practical to use, because I think they have a lot of good potential, but right now it's you can't use them consistently across the internet. Next slide. So I'm going to sort of basically summarize the draft. So 8200 is defined. Hop-by options are identified by next header value of 0, and they must be the first extension header in the packet. One of the changes is only to allow one hop-by-hop option in the header, and this results in requiring that all hop-by-hop options be 8 octet aligned because the way the hop-by-hop option header, it has to be 8 octet aligned, and so if it was shorter, then you would need pads. I was trying to avoid that. As I'll talk about later, it turns out most currently defined hop-by-hop options are 8 octet aligned. And as part of this, I'm saying that nodes must discard packets with more than one option. Next slide. And the other big change is basically if you can't process a hop-by-hop option in the fast path, you know, or the processing must be done in the fast path. And then this is a change, and it's a significant change, is that saying here, otherwise you just skip it. And this in itself, I think, is, I think it will solve the dropping problem in that they'll still get to the next hop. But, you know, it also means that you're forwarding a packet with something you don't know what's inside it. So it's, I wanted to call that out. Another change is that section 4.2 in RFC 8200, you know, the first bits in the type field define what to do with the option if it's not recognized. And I'm basically changing it to 00 will mean skip this option, continuing processing, and then otherwise discard the packet. And the change here is to no longer require the sending of ICMP error messages, which I suspect is problematic at full speed. Next slide. And, you know, as I said, 8200 allows to control hop-by-hop processing by local configuration. And so I'm just suggesting that routers maintain a lookup table based on option type. So it would be very easy or quick to see if an option is supported in the router, and if not, follow what it says in the bits in the option type field, whether to just drop it or to skip it. Next slide. And so I went through the existing options, and this lists the options that are hop-by-hop options. There are some other options that are either deprecated or are destination options, destination header only options, so I'm not showing those. And I discovered that many of these are 8 octet aligned, but there are 3 that are not. And so these would either need to be deprecated or modified. One of them, at least at the time I wrote the draft, is still an ID, so that should be more possible. But the effect of this was not as severe as I was expecting. Next slide. And of course, then any new hop-by-hop options defined must have 8 octet alignment. It's probably also good to include when they should be sent. Do they need to be in all packets? Can they be in occasional packets? You know, using the path MTU option as an example, that those are particularly not intended to be in all packets, because in fact they only want to be in the short packets, not in the long packets, because otherwise they won't do what you want them to get through the network end to end. So I think this needs to be specified in any future hop-by-hop options. Next slide. So I'm going to attempt to go through the issues. I have these in, these are issues largely raised on the mailing list, and then some other things that's come up in offline discussion. And there might well be more. So, and this is loosely sorted in the order they were received. There was a request, can we allow hop-by options elsewhere in the packet? I think that's not a good idea. I think it would make it harder to process. I think the current IPv6 design of making them always be the first one is intended to make it easier. You don't have to look through the whole packet in the fast path to see if there's any there. I think I think that's a very good property. I don't think we want to lose that. Next was reduces flexibility to have only one hop by hop option and fast path only. And it is true, it does reduce flexibility, but our current amount of flexibility has made this not be useful across the end-to-end internet. Another issue is restricting options isn't the right approach. And it'd be nice if we didn't have to do something, in my opinion, but if we want to be able to use these, I think we need to do something different. And the next was, to require them to be processed in the fast path was too restrictive. I mean, the document could be changed to make this a should, do it this way unless you have a good reason not to. I mean, that certainly also covers software implementations. But we do have the issue about, if you do allow them to go to the slow path, then how do you avoid this becoming used as a denial of service attack? If you keep them in the fast path and you only process the ones that you are configured to do, then I think the router is pretty well protected against a denial of service attack, because you should be able to do that processing at speed. Next slide. There we go. And so this was a very active topic in the email thread. And so these are sort of all pulled together. But how many hop by hop options should be allowed? I'm proposing one, and it is restrictive. I agree, but different hop by options could be used in different packets. They don't all have to be in the same ones. Don't need to be in every packet. So obviously, it depends on the design of the option. The path MTU option is particularly designed to not be in all packets. And I think that could be, I mean, maybe a general comment here is that hop by hop options can be a very useful and powerful mechanism, but if they're overused, then it sort of breaks the ability to use them. And so I think they need, thinking about this in the future, I think we need to be careful about what we would define as hop by hop. Then there's the, would a different limit be better as opposed to any number? Could we have 2, 3, 4, etc.? And, I sort of wonder how much flexibility do we need? I mean, we know that the current mechanism isn't working end to end in the internet. Right now, the host can send as many as they want. With what I'm proposing, they would know they could send 1 per packet. That's fairly easy to understand. If it's a different limit, then you have to have a way of, the host need to know how many to send. And unless you also have the requirement for 8 octet alignment, that you may need to use the pad options, which makes it more complicated. And then the last one was if there's more than one, should this be a global or a node limit? And I think it probably wants to be global. Hosts need to know what the limits are. Because if you send less than, it's fine, but if you send more, then the packets can be dropped. Next slide. And then another set of issues, is it better to keep ICMP error messages? I'm proposing to not do that. I wonder how practical it is. Is this, I think routers have mechanisms to limit the number they send, but if you're not sending them consistently, they may not be getting back to the source. So the source can't take any actions. I think this is a sort of an open question. There was a question about relationship to SRH, but SRH is a routing header, does not have hop by hop properties. It's processed by the node identified in the destination address of the packet. So the nodes in between that shouldn't be looking at them. Of course, any router, any node can look at anything if they choose to. We don't. We're not the protocol police. Will forwarding packets with unknown hop by hop options work at the edge? I think that's a good question. Right now we have examples of, ISPs at the edge dropping packets with hop by hop options. Will they let them through? Will firewalls and the like allow hop by hop options they don't understand through? That's, I think, something we need to understand better. And then the general question is operational deployment possible? This can require changes in all nodes to be useful. And I think clearly this will take time. It's going to require, and of course, require support from router vendors and operators. Vendors have to build this in, and operators have to decide it's useful to allow it to be used. And again, I think this comes back to, are the hop by hop options that are currently or will be defined actually useful? And that's I think a harder problem to grapple with. Next slide. And so thanks for all the feedback and editorial comments. I don't address the latter here. We clearly need to hear from router vendors and operators about this. Would they be willing to support something like this and enable it, or just continue the current behavior? And then the general question is this document, but particularly does the working group want to work on this? So
I think we have a microphone queue already. Ron, do you want to go ahead?
Yes. If you look today, you'll find many drafts trying to repurpose bits in the base IPv6 header, because what they really need is a hop-by-hop extension header, but they don't have one that works. So for that reason, I think that this draft is probably the most important draft in 6-man today, and should probably go to the top of our priority list. The second comment is the draft is both important and difficult. The reason it's difficult, HBH as it is today is unimplementable, because the HBH can be 2K long. It can carry 1,000 different options in it. Obviously, nobody can implement that. So you need to be able to you need to scale it back, but the question is how much. One problem is you need to be able to predict the future. You need to be able to predict future requirements. We can't see the future. To make it worse, we can't even see the present. We don't know what a minimum acceptable requirement would be, what a good number of a good number of forwarding engines would be able to process. We don't know if 1, 2, or 3 options is right. We don't know quite what every vendor what a reasonable minimal standard would be. But in any event, important work. Please keep going.
Excellent. Thank you, Ron. Fernando, you're next.
Can you hear me?
We can hear
you.
Oh, so so my comment is that as much as I would like to see the situation with extension headers improve, I don't think that the specific proposal of limiting the number of extension headers or the options within the extension headers will help much. what I see from the work that we have done in B6Ops is that the biggest challenge is that, you know, the ultimate length of the extension header chain. So it doesn't really matter that much how many options you have within the header or how many headers you actually have. But the point is, at the end of the day, what's the length of the extension header? You could have, for example, a single, a single hop-by-hop options header, but which has a single option that is quite long, and that would still be a problem. So if one wants to do this kind of thing, like, you know, let's say limiting or constraining the extension headers in a way that, you know, might help them survive in the internet, I think that the goal, or what one should be targeting, is to target the extension header chain length, as opposed to the number of you know, headers or the number of options you know, within the header.
Okay, thank you, Fernando. Cheng Li, please go ahead.
Monica and Fernando, I do really think the extension, the solution to address this issue, hop-by-hop issue, is really important. But it seems like if the devices will drop the packets when it meets the hop-by-hop header, so this solution cannot work as well. So I don't see how this mechanism can address the issue. And also, I agree with Rombonica that we do not know how many options we will need in the future. We cannot say that in right now. So I'm not really sure that it is a good way to go. But I would suggest that if operator build their new network, it would possible to like list requirements that every device should support hop-by-hop processing. That will solve the address. That will solve the issue. I think. Yeah. Thank you.
Thank you, Eric. Please go ahead.
So this is indeed a problem to be addressed. This hop-by-hop are not supported over the internet. I guess it's mainly because originally hop-by-hop was a vector for DOS, so it was shut and cut at the edge. But besides this, I think even if the problem is solved, hop-by-hop over the internet, over a multi-AS system, will never be followed and executed, right? We know that diff-serve code points, for instance, are only applicable within one domain. They are completely ignored once you leave your own domain. And this will be the same for hop-by-hop. So the limitation of a single option into the hop-by-hop extension header will not change this anyway over the internet, but will prevent innovation and extension within a single domain. And that's why, honestly, I do not like too much this proposal. And then the last point, putting a mass drop hop-by-hop extension headers having more than one option should most probably become a should or may, because the mass is too strong. It forces all the routers on the path to inspect hop-by-hop, which is in itself a kind of a DOS. Anyway, this is a problem to be addressed, so, but I don't have a solution here.
Right,
Thanks,
but I
Eric.
mean, the definition of hop-by-hop is that the routers are supposed to look at the option. I mean, that is what it is.
Indeed.
Thank you, Eric. Jidong, you're next.
Hi, I agree with the other people that this is a really important work, and that this hop-by-hop external header has been designed for this hop-by-hop forwarding, and a lot of features require such kind of functionality. Well, I understand that limiting it to only one option may encourage the implementation and help its deployment in a larger network. Is it possible to allow maybe a few more options in a limited domain? This may also help to encourage the flexibility in using this extension header for wider applications. Yeah.
Okay, thank you. Suresh, please go ahead.
Hey, Bob, like this is a really good draft, and I think this problem should be explored for sure. And so this is something like I think we've been trying to do for like about 20 years now. Like if I understand correctly, right? Like studying with like I had a draft like I think in 2003 or so, like looking into the same thing. I think the important thing, Bob, like which I think you are trying to nail down correctly, is like to reduce the barrier on routers to look at the stuff, right? Like trying to limit how much cycles they need to put in. I think that's the right direction to go, because like if we don't have some way of limiting how much time a router is going to spend on a packet, like nothing is ever going to happen. So I think as long as you can keep that envelope down, I think it's like a positive move in there. But and going back to Eric's comment, right? Like we don't know if this is going to get routers to widely implement this and let's packet through, and also to Fernando's point. But I think this is worth trying for sure. Thank you.
Thank you.
Thanks, Suresh. Gian is next. Please go ahead. Hope I said your name correctly there.
Yes. Hi, this is Gian Mishra with Verizon. Yeah, so Bob, this is definitely a really important subject. I think, I guess with a lot of other applications wanting to be able to take advantage of HPH, and at this point, HPH is really not a viable option to be used really for any type of application. The problem is definitely multifaceted and many layers to it. I think one of the big layers that I think that was mentioned is, I guess, the Christmas tree extension header. So that is something that that's a difficult variable right there. The other one that's also big is chip manufacturers and really the control of what the vendors use. Whether they use fixed function ASICs versus NPUs, which have better processing capabilities, and that's a variable that's kind of out of our control. And even the vendors, they'll pick one versus the other, and then you run into issues. So that's another major variable. Another issue that exists is that, I guess, getting the operators really to understand, I guess because they've had the understanding just the separation of control and data plane, and just the fear that the impact of the management plane, even once we kind of get through it and we're make progress trying to change the mindset that there could possibly be impact in the drop. The kind of the standard is to drop HPH due to worry of impact of the management plane. So that's another difficult like operational caveat of how to make HPH viable. Another idea which is closed domain versus public domain, and this is in the framework, is if you have a closed domain where you're just within your operator network, but you have like an underlay overlay. And there are many cases where a service provider core network may actually carry the internet routing table either in the global table or in a VPN. And this is in one of the other HPH drafts that we reviewed on the on V6 Ops related to this concept. That was something that I'd added to that draft. But what it boils down to is like if you do separate it out and you have your internet traffic carried in a VPN, your underlay is actually not impacted by the flows, by the HPH options, because now it's in the payload. So that's another caveat that exists. So operators are not as impacted if you are carrying internet traffic in an MPLS and an overlay versus sitting in the underlay. If you're actually sitting global table, now you're impacted. Your operator internal network's impacted, as well as any peering points are impacted. end to end, you're impacted by HPH options. So that's another impact. And then I think what Bob is trying to do, I guess, limiting the HPH processing by reducing the number of limiting the number. I mean, I think that's definitely a valid attempt to try to help the processing, so we're not punting everything to the control plane, and that helping with that separation of control plane and data plane. So I mean, I think that is definitely helpful. I think fine tuning and trying to figure out a way to stop the cycle of continuing down the road of operators dropping all HPH and trying to make headway. It is a very complex and multifaceted. So definitely, but good work, and I think it's something that we really need to continue to figure out a solution for. Thank you.
Okay, good. Thank you.
Thanks, Gian. Cheng-Li, you are next.
I think this issue is really important, and we have a lot of
notification innovation based on hop-by-hop extension header. So it is worth to discuss the solution. And we do have like new hop-by-hop extension header draft, something like this. And I heard some other solutions as well. So we can like combine together to discuss how to address this issue. Yeah, thank you.
Thank you. Igor.
Hi, this is Igor Vishansky with Verizon Media. One of the big issues with extension, and especially hop-by-hop options, is that there's a lot of data center class devices that are actually used out on the internet that are limited to, let's say, 120 byte parse. So I think I'd like to echo what Fernanda said, and the size of the option is actually a bigger issue than the number of options. And if you're limited to only 120 byte parse, that doesn't leave a lot of room for hop-by-hop options.
Okay, but that, I mean, that is clearly a number that will change over time.
That is absolutely the number that will change over time. However, that number's been around for several years.
Okay, well, this would be good to hear from the folks who make this to talk about that. Not probably right here, but thank you.
Thanks. And Mackerman, you are in the queue. Feel free to state your full name. We cannot hear you. Yeah, okay. I think we'll move on. So lots of comments, Bob. I think it's perhaps not ready for an adoption call. I think we'll continue this on the mailing list.
Hi, this is Mike, and I was muted. Can you guys hear me now?
There you are. Please go ahead.
I'm so sorry about that. I just want to say I'm with an enterprise, and a lot of us are not deploying IPv6 because we think it lacks some management and control and other information that I think hop-by-hop could provide very nicely. So I think this is really important work, and I hope it continues. I have a couple issues or questions along the lines of what both Igor and Fernando and Eric said, but I think those can be worked out. So I really hope this continues, and I think it'll be real strong work. Thank you, Bob.
Thank you very much.
Thank you. And Gori, you have the last word on this topic.
I'm just going to say thanks, Bob, for presenting. And both authors are really serious about taking inputs on this. We want this to work, so please talk to us. And please adopt it next time round, please.
Excellent. Thank you, Gori. And Fernando, I think you have the last presentation of the day. Please step into the pink box.
Okay. There you go. Can you hear me?
We can hear you.
Good. Okay, so this is me again, presenting the document on the scope of unique local IPv6 unicast addresses. Next slide, please. Before getting into the into the topic itself, let me discuss a little bit how how this issue came up. I was doing an IPv6 training course, and I was essentially explaining the IPv6 architecture, and I had questions asked about the scope of addresses. So I wasn't that sure, so I checked the specs regarding, how the scope was defined in the, scope addressing architecture, the IPv6 addressing architecture, the ULS specification. And then I found that there were conflicting uses of the definition of scope. So I said, okay, well, it's not nice that, if I wanted these folks to, if I wanted to refer these folks to the, actual architecture and specifications, they find stuff that is conflicting. So that's how I, ended up raising this, this topic in Sixman. So essentially, we have like conflicting usage of scope in different IETF standards. There's 4007, which is the scope addressing architecture. There's 4291, which is the IPv6 addressing architecture. And then we have the specification for ULAs, okay? Now, if you wonder, okay, why should I care about this, or should I care about this? This is how I see it. The, let's say, issue that we have is that if you try to understand the architecture from, in this respect, we are talking about the scope, from the current documents that we have, since they are, conflicting, that's difficult. So, among people, that the people that, devote a lot of time to this, well, might be conflicting, but, well, we kind of like all understand what we mean, even if we don't say it. But, for folks that you'd like to refer to the specs, you have to explain, well, the terminology is not exactly very precise. If you wonder, well, is something breaking as a result of this? No, certainly not. I mean, this is mostly a definition thing or an architectural thing, and certainly definitions will not cause networks to break. So there's nothing that is breaking as a result of this, just to make the point clear. Now, there are practical implications of this, and we will discuss one of them, because there are cases in which the semantics of IPv6 addresses matter, and that's where definitions kick in. And if when we will see quite clearly that when the definitions are not clear, there will be issues there. Next slide.
Do you want to take a question real quick?
Yeah,
Tim
sure.
Chown
Yeah, sure.
just jumped into the queue. Please go ahead, Tim.
Hi, Fernando. Just hopefully a simple question. What are the conflicts? You say there are conflicts in those 3 RFCs, but I don't immediately know what those conflicts are.
It's in the next few slides. So I will describe that like clearly.
Okay, thank you. Sorry.
And well, so let's talk about the definition of scope. So this is what we have in 4007, okay? Scope is defined as the topological span where within which an address may be used to uniquely identify an interface, okay? That's the scope. And global scope, as a result of that, means that if an address has global scope, it means that it uniquely identifies the address, the interface, sorry, anywhere in the internet, okay? So a global address is supposed to uniquely identify an interface anywhere on the internet. ULAs, we will go into detail later, but from the very beginning, obviously ULAs don't conform to that. Why? Well, because you are randomizing the prefixes, and if we happen to have for some reason randomly we ended up selecting the same prefix, obviously the resulting addresses will not uniquely identify an interface anywhere in the internet. So that's first reason. Next slide. Then, if you want to add a little bit more to that, this is the scope definition, in 4193, which is the ULA specification. So it says, on one hand, okay, these prefixes are globally unique. Well, we will see the next slide about this later, but they cannot really be globally unique if they are being randomly generated in an uncoordinated manner. That's not possible. But then, if you continue with the same definition, they say their limitation is in the rootability of the prefixes, which is limited to a site and any explicit, routing agreement. So in essence, what the definition is telling you is that these addresses are limited to a site, which is when they are meant to be employed. Now, next slide. Now, when discussing, the scope of ULAs, normally people say, "Oh no, but that's not correct." If you look at the ULA specification 4193, you will have the math there that, well, okay, it doesn't say that the addresses are unique, but it essentially tells you that the probability of collision is, really low, so low that in practice you can claim that they are unique. Now, if you really think about what 4193 is saying, what it's really saying is, if you grab a reduced number of ULA-based networks, and you interconnect them, then this is what the probability of collision will be. So you connect only 2 networks, then you get, blah, blah, blah. You connect 10 networks, you get this probability. You connect 10,000 networks, and you get this number, which is still low, you could say. But based on the definition that we have from global scope, which was in the previous addresses, in order for ULAs to really be global scope, that means that absolutely all of the ULA networks, when interconnected together, should have a small probability collision. Now, if you compute the birthday paradox about the math of interconnecting all ULA-based networks, the number wouldn't be 10,000, of course. There's no only 10,000 deployments in the internet. That would be, I don't know what's the number, 10 million, 100 million, I don't know what's the number. Now, when you compute the birthday paradox for that number, then now the probability of collisions becomes roughly 1. So you are guaranteed that you will actually have collisions, okay? Now, based on the definition that we had before for what's a global scope address, well, then ULAs can obviously not be global scope, because if you have almost certainty of collisions, then you cannot claim that the ULA uniquely identifies an interface, okay? Next slide. Now, some practical implications, because you could say, okay, well, the definition is not really precise. Well, okay. Now, this is an interesting, case. This was raised by, Brian, so credit goes for him to spotting this one. There's a library in Python which processes IPE addresses, okay? Including them, it processes IPv6 addresses. And for each address object, it has some attributes, okay? So, you set some address and, the attributes will be set accordingly. You can check for those attributes. So there are 2 attributes which are specified by the library as follows. Is private, which is true if the address is allocated for private networks. Is global, which is true if the address is allocated for public networks. And what happens if you have a ULA? Well, private is set to true, global is set to false. Now, you might say, okay, well, these guys are wrong. That might be, an option. But when you look at the actual definition of, scope that you have, you cannot really blame them. Because, from when it comes to the definition of scope and global scope itself, ULAs cannot be global. ULAs don't comply with the definition of global. So here you have like a practical case. So is this library right or wrong? I would say that, from a conceptual point of view, they are right. If you ask whether they are compliant with the specifications, I would say, I don't know. I mean, there's a conflict in the specifications. So they might, I think that they comply with 4007, because this is, what I interpret the scope of ULAs to be. But this doesn't comply with, let's say, 4291, because 4291 lists ULAs as global addresses. So this is, again, practical case. What do you do in this case? Like, do you ask them to fix them, and why? Are they wrong? Are they right? So this is a case where, the semantics and the definitions do matter, but, because of the conflicting specs that we have right now, you cannot really tell what this guy should do with the library. And this is just one case. So this is one case spotted by Brian Carpenter. There might be others, okay? I don't think there are any, but, you do have also macros, that you can use in the, when you code in C to check some things. As far as I remember, there's no macro that will check for this, but there might be in the future. And then again, you need to be able to tell, what's global and what's not. Next slide. So this is what our document proposes, okay? So this is when first version of the document. This is what we propose to do. Essentially, what we said is the easiest way to do it is to simply update 4291 in the part that says just specify the ULA prefix, because right now what you have is like you have a lot of listed prefixes, and what 4291 says is that, well, unless otherwise noted, the addresses are global scope. That's what the spec says. And since it doesn't, have anything special about the ULA prefix, by default, they're global. So what we say is that, update 4291 in the sense that now you mark the ULA prefix as something else. What you want to call it, I don't care about the name. Could be private addresses, domain local addresses, whatever. I mean, for me, the name doesn't matter. Like, no, it's for the working group to select that. Since there is text in 4193 that essentially claims that ULAs are global scope, this is the update that would be necessary. In the update for 4291 is like a one-liner. When you have the list of prefixes, you just add the ULA prefix and you say this is something else scope, something else address type, whatever name you want to use. For 4193, there is a part in which talks about ULAs being global scope. So the fix is simple, and is the text that we have here, essentially saying that whatever term that we use to define the scope in 4291, we would reuse that term here. For example, the scope of these addresses is local. And how do you find the scope? Well, larger than link local and smaller than global. It's something in between. You don't really know where the scope ends because you can't. You can't. And the other thing that is necessary is that in the IANA IPv6 special purpose address registry, where you have like essentially pointers to RFCs, that explain the different address types, essentially have the entry that describes ULAs pointing to this document. Next slide. So these are among the the possible options. First option is adopt this document as a working group item in the hopes of working or trying to fix the ambiguity, for example, in the way that we are trying to to fix it in our document. But there are other options. I have a preference for the first one. Another option would be, okay, if there are conflicting definitions, like we could, for example, do a 4007 bis. There are other things to be fixed there, and those have been, discussed on the mailing list. But, if you want to keep the same definitions for ULAs, like claim that ULAs are global, we would end up, changing 4007, and we would, we would have to come up with a definition of global that I would say would be quite interesting. So, yeah, I mean, you can change the definition, but I think that the only definition that would fix this would be counterintuitive to what you expect global scope to mean. Then obviously there's always the option of do nothing. Okay, I personally think that that's not attractive. If this was something that was like let's say conflicting definition in IPv4, you might say, okay, well, we are supposed to get rid of IPv4. Well, at least we have the hope for that. But in the case of IPv6, I guess we all expect it to be around for quite some time. So I don't think that of having something that is conflicted and that you cannot really point people, like you cannot refer people to actually better understand the topic is like is an acceptable way out. Like I would have liked it in that case where I had the discussion to point to tell people, okay, well, go and read this and this document and everything will be clear. Now, if I had done so, well, they would have probably came up with this, like, well, what you told me to read doesn't make a lot of sense. So this is for the working group to discuss.
Okay, Jan, go ahead.
Hello. Fernanda, I have a few comments. First of all, I kind of still do not see a real problem here because I think what we're talking about here is a different way to interpret a couple of RFCs. Because I believe the ULAs are actually unique if they used properly. The same way normal global addresses are unique if used properly, because I see people just using random addresses assigned to other companies and putting them in their network, right? In this case, we cannot call any address unique because it actually could be a duplication if someone does the wrong thing, right? Also, I do not think you ever expect to get 10,000 network fusion ULAs interconnected, right? The probability of being unique are rather high in the expected use case. I don't think it's a real problem. And again, I do not think that existence of one library, which probably could be fixed, and as discussed in the chat, Brian actually has suggested ways to fix it, should be a reason to do such a drastic change. And now let me explain why I think we shouldn't change the scope. If we change the scope, we will get a problem with scope address architecture. When I use my ULA source to reach the global destination, looks like I cannot because the router is not supposed to forward it, right? Because now the scope of the source address will be less than the scope of destination, and the packet will leave the zone. So I suspect there are plenty of use cases when people might use the ULA source to reach global destinations. I think it's a kind of dangerous change you're proposing there.
Two comments about that. Like, I agree with you that you wouldn't end up interconnecting more than 10,000 ULA networks. Probably I would say that you wouldn't even interconnect like 100 of them, most likely. Okay, not even, let alone 10,000. What I'm saying is that what the definition says, okay, is that they still need to be, if it's global scope, global implies the whole internet. Then if you connect them or not, that's a different question. I agree with you that you wouldn't interconnect them, but the definition says that if you claim that something is global scope, whether you interconnect them or not, that's a different issue. You could block them. That's a lot of things that you could do. But what the definition says is unique internet-wide for global scope. That's in one of the previous slides that I discussed. It doesn't say global scope is unique in the area where you decide to use it. That's different. So I agree with what you say, but what I'm saying is that the formal definition doesn't agree with what you're saying. Global implies the whole internet, not where you decide to use it. That's the formal definition of global scope. Only, can we go back a few slides? I think it's like,
well, so why don't we, Fernando, why don't we get the other people in the queue?
Yeah, please.
Fred?
Yeah, thanks for the presentation, Fernando. I just wanted to point out that in addition to LLAs, ULAs, and GUAs, we also have host identity tags, HITs, from RFC 7401. And they are more preferable than ULAs in some cases, but less preferable than a true GUA in other cases. Can we somehow fit that into the hierarchy?
Well, definitely, I think it was David Farmer that he also writes it, not just the case that you write, but even other ones. So definitely, yes, there are other cases. So in this is the one that, the one that, popped up the issue. But I do agree with you that there are other cases that, most likely follow the same principle.
Ollie, I think you're muted or something.
Bob, you're in the queue. That was the only thing I intended to say.
Sorry. So, thank you. So I'm one of the authors of the ULA spec. So I'm speaking in that regard. I actually don't agree with Fernando's proposal here. I think the spec is actually fairly clear about the level of uniqueness, and it's also very clear about the way ULAs are intended to be used, and I'm not hearing any kind of operational problem that this is causing. I think this is, I'm not sure if I want to use an academic issue, but I don't think this is worth the benefit. I think of changing anything here is very small, and it potentially also does harm in that it's going to maybe cause more confusion than there is now about this. And just to nitpick a little bit, I think the birthday paradox analysis isn't quite right, because the intention of, like, when the draft talk, the RFC talks about how you might use this in VPNs between some number of, say, enterprise sites, and to do that you would get your ISPs to coordinate advertising the prefixes. There was never intent that the prefixes would be routed globally to everywhere, like RAR-based prefixes are. So the chance of a collision is practically zero. So I'm not sure. I'm not hearing any kind of problem that I think is worth solving. Thank you.
Thank you, Bob.
Yeah.
Well, okay, go on, Fernando. Yeah, quick.
So the comment is that so this is in this slide is where we they have the definitions that we are referring to. So I agree with that. You say that, okay, within the scope or within the area, let's not say scope, because that's a formal definition. If you say within the area that I would end up using the ULAs, they are going to be unique. Agreed, fully agree with that. Now, the way in which 4007 defines scope is like this. And global scope means the whole internet, not where you decide to use them. That's what I'm referring to. Now, if you say, okay, this is, let's say an academic definition, I mean, in a way, yes, but, architecture is academic if you want. Doing an architectural document is academic. And then there are implications, like there's the Python library example that I mentioned. Is it okay? Should them fix it, and why?
Yeah,
thanks.
Just argue that it's a bug.
Thanks, Fernando. Mike, you have the next, and then we have Eric to end the day. Mike, please go ahead.
Okay, thank you, Michael Ackerman again. And again, from the enterprise perspective, we're wrestling with deploying of IPv6 now. One of our issues is, what do we do for situations where we currently use 1918 addresses for various reasons? And we think that EULAs could be a good answer there, but quite frankly, we don't understand them and what the scope is. And like one of Fernando's slides said, we come out somewhere between link local and the entire internet. If this document could lend clarity to that, that would help us out a lot in terms of getting deployment. I'm afraid I'm in support of it. Thank you, Fernando.
Thank you.
Okay, Eric, you have the last word for the 6-man in Prague.
Virtual Prague. I just wanted to say that the Python library goes back to, I think, some very early IP address library work around 2008 or 9 at Google by various folks. So it's pretty, some of that stuff's pretty old. And also, Brian Carpenter's draft about what does global mean talks about some of this stuff. But I think, the difference between global addressing and global routing is a key realization. And that IP address library did not, at the time, take any of that into consideration. It was, meant simply to try to disambiguate clearly global addresses from other things. So, and also the temptation to try to map ULAs onto RFC 1918 may have been present, and it's that mapping is imprecise. So,
just for the record, it's not that I'm suggesting that the scope of ULAs is mapped to that of 1918. I'm just saying that based on this slide that we have here, based on this definition, it cannot be claimed that ULAs are global. That's it. What
I think the API has that is private flag, right? And that's clearly applicable to RFC 1918, and was probably extended because that was the limit of the understanding, or that was the most proximal understanding at the time. That's
Uh-huh.
Okay, thank you, Fernando. I think we are done with today's session. We'll continue on the mailing list, I'm sure. Who knows if we meet physically in the summer? Probably not, but it's in San Francisco time zone, I think. So thank you very much, and we'll see you on the mailing list.
Yes, thank you all, and see you
Thank
in
you.
Saturdays.